Steel weighing 1,350 tons, a barrel stretching 150 feet, shells tipping the scales at 7 tons apiece, a range reaching 29 miles. Schwerer Gustav stands as the largest gun mankind ever built, a weapon so massive that operating it consumed 2,500 men and positioning it for firing ate up 5 weeks. 10 million Reichsmarks bought this monster. Resources that could have produced nearly 100 tanks, and across its entire combat career, the gun fired exactly 48 rounds before the barrel wore smooth. All this effort, all this engineering genius, all this draining of Germany's wartime resources produced a gun that accomplished almost nothing conventional artillery couldn't have done for pocket change. What follows is the story of Nazi Germany's most spectacular failure, a weapon representing the absolute peak of bigger is better, thinking pushed to absurd extremes, and a monument to the danger of solving yesterday's problems with tomorrow's resources. Our story begins not with Adolf Hitler or the Second World War, but with France in the aftermath of the First. Trenches from 1914 through 1918 traumatized an entire generation, and the French swore never to fight that kind of war again. So through the 1920s and early 1930s, they constructed the Maginot Line, a series of fortifications along the Franco-German border representing the strongest defensive system ever built. Concrete bunkers buried deep underground, interconnected tunnel systems, retractable gun turrets, anti-tank obstacles, and garrison facilities housing thousands of troops indefinitely made up this wall, making invasion of France impossible, or at least so costly that no rational enemy would attempt it, drove the entire design. And by the mid-1930s, as the fortifications neared completion, Germany's military planners stared at this wall of steel and concrete and asked themselves a simple question: how do we break through it? 1934 brought the German Army High Command, the Oberkommando des Heeres, to Friedrich Krupp AG, the heavy industry conglomerate based in Essen that had been making weapons for Germany since the 1880s. The commission was straightforward enough: design a weapon capable of destroying the deepest and strongest fortifications the French had built, and the specifications came clear: penetrating 7 meters of reinforced concrete or 1 meter of solid steel armor, firing from beyond enemy artillery range so German forces wouldn't face counterfire, and reducing these fortifications to rubble before German infantry made their assault defined the requirements. Krupp's engineers went to work preparing ballistics reports for guns of various calibers, running calculations for 70 centimeter, 80 centimeter, 85 centimeter, and even 100 centimeter weapons. And the math showed that an 80 centimeter gun could meet all requirements while remaining at least theoretically possible to build with existing metallurgy and manufacturing capabilities. Krupp dutifully filed the reports with the Army, but took no further action because peacetime meant no urgency to actually construct such a weapon. March 1936 changed everything when Adolf Hitler made a personal visit to the Krupp factory in Essen, and during his tour, he asked Gustav Krupp von Bohlen und Halbach, head of the Krupp organization, what kind of weapon would smash through the Maginot Line. Gustav Krupp, recalling the recent ballistic studies his engineers had prepared, answered Hitler's question in considerable detail by explaining that an 80-centimeter railway gun could be constructed and would defeat the Maginot Line's strongest fortifications. Hitler latched onto this immediately and pressed for more information. And while he didn't commit that day, the meeting lit a fire under Krupp's engineering department. Design work began on an 80-centimeter model in late 1936. The resulting plans were completed in early 1937 and submitted for approval, and when Hitler saw the detailed designs, he gave his approval for construction to begin. What emerged from these plans carried the designation 80-centimeter Kanone, E, with the E standing for Eisenbahnlaufett, meaning railway mounting, but it quickly became known as Schwerer Gustav, or Heavy Gustav, after Gustav Krupp, who had first explained the concept to Hitler. 3 guns were ordered initially, with Hitler demanding that the first be ready by March 1940, when the Battle of France was expected to begin. And Krupp promised to deliver, though their engineers knew the timeline was optimistic at best. Staggering specifications defined the final design: An 80-centimeter caliber made it 800 millimeters or 31.5 inches across the bore, larger than any gun ever seriously contemplated, much less actually built, and the barrel stretched 32.5 meters, working out to 106 feet 7 inches of rifled steel tube. Length and weight forced the barrel's construction in two halves that would be joined together during assembly, with the rear half covered by a massive steel jacket to handle firing pressures. Fully assembled, the gun measured 47.3 meters from end to end, translating to 155 feet 2 inches, or about half the length of a football field, and it stood 11.6 meters tall, roughly 38 feet high, or the height of a 4-story building. Width came to 7.1 meters, or about 23 feet, and total weight when everything bolted together reached 1,350 metric tons, approximately 1,490 short tons, or about the weight of 1,350 small cars. Rifling inside the barrel ran 10 millimeters deep, with grooves spiraling down the tube's length, to spin the massive projectiles and stabilize them in flight. And attached to the barrel's rear sat the cradle and breech block assembly. 4 massive hydraulic recoil absorbers mounted to the cradle handled the tremendous forces generated when the gun fired, because without them, the recoil would literally tear the mounting apart. And trunnions held the gun's cradle in 2 huge carriers, enabling the barrel to elevate from 0 degrees, essentially horizontal, all the way up to 65 degrees for maximum range. 2 ammunition types were developed for Schwerer Gustav, both absolutely massive. High explosive shells weighed 4,800 kilograms, working out to 10,582 pounds, or 5.29 short tons, and could be fired to a maximum range of 48 kilometers, or 29.8 miles, with a muzzle velocity of 820 meters per second, or about 2,690 feet per second, designed to destroy surface targets through blast effect and fragmentation. Armor-piercing shells topped the scales at 7,100 kilograms, translating to 15,653 pounds, or 7.7 short tons, nearly 4 times the weight of a small car packed into a single projectile. Effective range reached 39 kilometers, or 24.2 miles, slightly less than the high explosive round because added weight meant it didn't fly quite as far. And it was designed specifically to penetrate deep underground or through massive concrete and steel barriers before detonating. Rate of fire crawled because the barrel had to cool between shots to prevent warping or cracking from intense heat generated by firing. 1 round every 30 to 45 minutes marked the maximum sustained rate, which meant that in a full day of operation, Gustav could fire perhaps 20 to 30 shells if everything went perfectly, and barrel life was estimated at approximately 300 rounds before the rifling would wear smooth, and accuracy would degrade to the point that the barrel needed factory relining. Actually building such a weapon presented engineering challenges that pushed Krupp to their limits. Each gun required individual fabrication because nothing this large had ever been attempted before, and no standard procedures or equipment existed for forging steel components of this size, and technical complications became apparent almost immediately. Massive steel pieces needed for the barrel, the breech block, the mounting, all of it pushed the boundaries of what Krupp's factories could produce. And forging the barrel sections proved especially difficult because the steel had to be absolutely uniform to handle pressures without cracking. Late 1939 made clear that Hitler's March 1940 deadline was impossible to meet. Krupp built a test model and sent it to the Hillersleben firing range where penetration tests were conducted, and results encouraged everyone because the 7.1-ton armor-piercing shell penetrated the specified 7 meters of reinforced concrete when fired at high elevation, which meant the gun could do what it was designed to do, but actually producing a combat-ready weapon took far longer than anyone anticipated. September 10, 1941, brought the first test round, fired from the commissioned gun barrel more than a year and a half after Hitler's original deadline, and this came from a makeshift gun carriage at Hillersleben rather than the full combat mounting. November 1941 saw the barrel transported to Rügenwalde, now Darłowo in Poland, and 8 additional firing tests were carried out, using the 7,100-kilogram armor-piercing shell out to a range of 37,210 meters, or about 23.1 miles. Early 1941 brought Adolf Hitler to the formal acceptance trials at the Rügenwalde Proving Ground, and Alfred Krupp, Gustav Krupp's son, personally hosted the Führer and walked him through the gun's capabilities. Hitler was reportedly awestruck by the sheer size and power, and accounts exist that he commanded an 11-ton shell, if such a thing existed, could only be used at his personal discretion, though he apparently never gave permission for this hypothetical super shell. And it's unclear whether such ammunition was ever actually produced, or if this was just Hitler being dramatic about a theoretical maximum load. By the time Gustav was finally ready for deployment, the Battle of France was long over, which created an immediate problem because the gun had been designed specifically to destroy the Maginot Line, and now there was no need to destroy the Maginot Line because it had been bypassed and made irrelevant. A May and June 1940 brought the German Wehrmacht's blitzkrieg offensive through Belgium that simply went around the fortifications, outflanking the entire defensive system and forcing France to surrender without the Maginot Line ever being seriously tested. Schwerer Gustav, the weapon that was supposed to smash through France's strongest defenses, had taken so long to build that it arrived too late to do the job it was designed for, and now the German military had to find something else to shoot at with their 10 million Reichsmark gun. Building the largest gun in history created a fundamental problem from the moment construction began. The thing was too large to actually move anywhere, and this issue plagued Schwerer Gustav throughout its existence. Moving the gun as a single piece was impossible because it exceeded the loading gauge on German railways, meaning if you tried moving it intact, it would smash into bridges, tunnels, platforms, and basically every piece of infrastructure along the route. Breaking Gustav down into components for transport and then reassembling it at the firing position became the solution, which sounds straightforward until you grasp the scale involved. Dismantling the gun produced the breech ring and breech block. The barrel split into two halves, the barrel jacket, the cradle, the trunnions, and the mounting, which itself was split lengthwise into two halves, and the bogie units that ran on their own wheels. And all these components were loaded onto special flat wagons designed specifically for this purpose. When Gustav was on the move, it required 25 railway cars and a train that stretched 1.5 kilometers, or nearly a mile long. Equally absurd was the rail system required for actually firing the gun. Gustav was mounted on a specially designed chassis supported by 8 bogies running on 2 parallel railway tracks. And each bogie had 5 axles, which meant the entire assembly rode on 40 axles or 80 wheels total. But you couldn't just roll this monster onto any track and start shooting, because the gun needed a complete 4-track system to function properly. 2 inner tracks supported the gun's bogies and carried the actual weight of the weapon, while 2 outer tracks were required for the massive cranes that would assemble the gun in the first place. At each firing position, German engineers had to build semicircular track sections, so Gustav could traverse, because the gun had no ability to rotate on its mounting, and could only adjust elevation up and down between 0 and 65 degrees, which meant if you wanted to aim left or right, you literally had to move the entire gun along a curved section of railway track. Assembly requirements reached peak absurdity here. Getting Schwerer Gustav from pile of components on railway cars to ready to fire required between 1,420 and 2,500 men, depending on which source you believe, and every source agrees the number was staggering. 250 men just to assemble the gun itself, another 500 to operate and fire it once ready, and somewhere between 1,500 and 2,000 more to lay track, prepare the site, provide security, handle ammunition, and perform the 1,000 other tasks required to support such a weapon. Time required was equally ludicrous. 3 weeks to assemble the gun once all components arrived at the site, and 5 weeks total, including site preparation before Gustav could fire its first shot. And remember, this was 5 weeks during which the gun sat completely vulnerable because it couldn't move and couldn't defend itself beyond the anti-aircraft battalions assigned to protect it. The assembly process itself was a masterpiece of engineering complexity. First, you built 4 parallel sections of railway track at the firing position, then positioned the bogies on the inner tracks, then built up the mounting components on top of the bogies piece by piece, and the barrel assembly required inserting the rear half into the jacket, fitting the front half onto that, and locking everything together with a massive junction nut that probably weighed more than a car. Then you fitted the complete barrel into the cradle, hoisted the entire assembly with the two 10-ton cranes running on the outer tracks, and lowered it carefully onto the mounting. Attaching the breech ring to the barrel's end using another enormous nut came next, and finally you slid the 20-ton breech block into place. And if you'd done everything correctly, you now had an operational gun, though if you'd made any mistakes during this 3-week process, you had to partially disassemble everything and try again. Command structure for this operation required one major general to command the entire heavy artillery unit, E-672, one colonel as second in command, and 2 complete anti-aircraft battalions just to protect the gun from air attack while it sat exposed for weeks during assembly and firing operations. Operational limitations proved crippling. Gustav could only fire in the direction the tracks pointed, and changing the firing direction significantly meant laying curved track sections or, in extreme cases, rebuilding the entire track system pointing a different way. Maximum range was 48 kilometers for high-explosive shells and 39 kilometers for armor-piercing rounds, which sounds impressive until you remember that conventional heavy artillery could reach 20 or 30 kilometers with far less complexity. Firing one shot every 30 to 45 minutes while the barrel cooled meant a maximum of perhaps 20 to 30 rounds in a full day if everything went perfectly. Barrel life lasted approximately 300 rounds before rifling wore out, and accuracy degraded to the point that you had to send it back to Krupp's factory in Essen for relining, which meant the gun would be out of action for months. Ammunition was limited because producing 7-ton shells was expensive and time-consuming, and for the Sevastopol deployment, the Germans apparently had only 48 rounds available total, though sources disagree on exact numbers. Air attack vulnerability during the weeks-long positioning phase when it couldn't move made it an obvious target. It required extensive railway infrastructure that could be sabotaged by partisans, and it was completely useless in mobile warfare where battles moved faster than Gustav could be repositioned. Cost was astronomical. 10 million Reichsmarks per gun, according to most estimates, though Krupp allegedly didn't charge for the first gun and charged 7 million Reichsmarks for the second gun, Dora, and either way the expense was staggering because, for comparison, a Panzer IV medium tank, the workhorse of the Wehrmacht's armored forces, cost approximately 103,000 Reichsmarks. Gustav cost the equivalent of 97 Panzer IV tanks. Or, looked at another way, Germany could have built nearly 200 Messerschmitt B, F-109 fighters, or bought fuel for thousands of vehicles for months. The fundamental flaw was that Gustav was designed for static siege warfare like World War I, while World War II was a war of movement characterized by blitzkrieg tactics, and by the time Gustav was ready, the entire nature of warfare had evolved past it. The gun took longer to position than most battles lasted, making it immobile, inflexible, resource-intensive, and tactically obsolete before it fired its first shot in combat. But the German military had spent 10 million Reichsmarks building this monster, and Hitler was personally invested in seeing it used, so they needed to find a war for Gustav to fight. Operation Barbarossa, Germany's invasion of the Soviet Union beginning June 22, 1941, finally gave Schwerer Gustav an opportunity to prove itself. General Erich von Manstein's 11th Army swept into the Crimean Peninsula in October 1941, breaking through the Perekop Isthmus after a 10-day battle that netted 100,000 Soviet prisoners and opened the door to the Crimea. But one objective remained unconquered: the heavily fortified port city of Sevastopol on the Black Sea. Sevastopol was no ordinary city. Multiple fort complexes, including Fort Stalin and Fort Molotov, extensive underground facilities carved into bedrock, coastal batteries that could engage ships and land targets, and defensive positions prepared for exactly this kind of siege made it a fortress, and initial German assault attempts in October and November 1941 were thrown back with heavy casualties. Manstein decided that Sevastopol would have to be taken through conventional siege warfare combined with overwhelming firepower. This was exactly the scenario Gustav had been built for, so February 1942 brought Heavy Artillery Unit, E-672's reorganization, and Schwerer Gustav began its long journey to the Crimea. The 25-car train stretched 1.5 kilometers and moved slowly along the overtaxed German railway system, finally reaching the Perekop Isthmus in early March 1942, where it was held until early April while engineers prepared the firing position. A special railway spur line connecting to the Simferopol-Sevastopol Railway 16 kilometers north of the target was built by the Germans, and at the terminus of this spur, they constructed 4 semicircular track sections specifically for Gustav to traverse. Outer tracks were for the assembly cranes, inner tracks for the gun itself, and work began in early May with 1,420 men laboring around the clock to assemble the weapon. Even without Gustav, the German artillery concentration for the siege was massive: 785 German medium and heavy guns, 112 Romanian guns, 3 600mm Karl Gerhardt self-propelled mortars named Thor, Odin, and a third whose name is lost to history, 2 280mm railway guns, 2 420mm howitzers, 2 355mm howitzers, and 4 305mm mortars. The Luftwaffe's 8th Air Corps under Baron Wolfram von Richthofen provided 600 aircraft, including 7 bomber groups. But Gustav was the centerpiece, the weapon that would demonstrate German engineering superiority and break Soviet resistance through sheer destructive power. And by June 5, 1942, after 3 weeks of assembly, the gun was ready to fire from its position 19 miles northeast of Sevastopol, protected by 2 anti-aircraft battalions and operated by 1,500 men, under the command of 1 major general and 1 colonel. Operation Sturfang, meaning sturgeon catch, began June 2, 1942. The Luftwaffe flew 23,751 sorties in June alone and dropped 20,528 tons of bombs on the besieged city, an intensity exceeding the bombing of Warsaw, Rotterdam, or London. And the German 11th Army fired 46,750 tons of artillery ammunition. Somewhere in that hurricane of steel and high explosive, Schwerer Gustav added its own contribution. Several targets were engaged over June and early July. 8 shells were fired at coastal gun positions at a range of 25,000 meters, or about 15.5 miles. The shells arcing through the sky and falling onto Soviet artillery that was harassing German positions. And 6 shells were fired at Fort Stalin, one of the major defensive complexes, the massive 7-ton projectiles smashing into concrete and earth with enough force to create craters 30 feet across. 7 shells targeted Fort Molotov, another fortification that anchored the Soviet defensive line. But the most spectacular shot, the one that justified all the effort and expense in the eyes of those who witnessed it, came when Gustav fired on a target called White Cliff, or Ammunition Mountain, an underground ammunition magazine buried in the bedrock beneath Severnaya Bay. The facility sat roughly 30 meters below sea level, buried under layers of rock and earth, and protected by the water of the bay itself, making it effectively invulnerable to conventional artillery. Gustav fired a single 7-ton armor-piercing shell at this target, and what happened next entered military legend. Smashing through the water of the bay, the shell penetrated through approximately 100 feet of solid rock and earth, and detonated inside the underground ammunition depot, and the explosion was catastrophic as thousands of tons of Soviet artillery shells, mortar rounds, and small arms ammunition cooked off in a chain reaction that shook the ground for miles. A massive fireball erupted from the bay, and smoke rose thousands of feet into the air, and the underground facility was completely destroyed, along with everything and everyone inside it. This was Schwerer Gustav's moment of glory, the single shot that demonstrated what the gun could do that nothing else could accomplish, because no conventional artillery piece could have reached that deep. No bomber could have penetrated that much rock, and destruction of this ammunition dump dealt a real blow to Soviet defensive capabilities by eliminating a major supply of shells for the defenders. But that one spectacular success has to be measured against the broader context of the siege. June 2nd through July 4th, 1942, saw the Germans fire 67,278 tons of total munitions at Sevastopol, including bombs and artillery shells, and the Luftwaffe flew constant sorties destroying Soviet attempts to evacuate by sea and pounding defensive positions into rubble. By the end, only 11 undamaged buildings remained standing in the entire city, and Soviet casualties totaled 200,481, killed, wounded, or captured. Gustav fired 47 or 48 rounds total, with sources disagreeing on the exact number, and those rounds contributed to destruction of some coastal batteries, damaged Fort Stalin and Fort Molotov, and destroyed one major ammunition depot. The rest of the 67,278 tons of munitions came from conventional artillery and bombs that cost a fraction of what Gustav cost and could be positioned in hours rather than weeks. 48 rounds wore the gun's barrel completely out. Remember, it had already fired approximately 250 rounds during testing and development, and total barrel life was only about 300 rounds before relining was required. So the Germans fitted the spare barrel they had brought with them and sent the original barrel back to Krupp's factory in Essen on a long journey across German-occupied Europe. July 4th, 1942, brought the siege's end when the remaining Soviet forces surrendered and the Germans seized the ruined port. Sevastopol had fallen, but it would have fallen with or without Gustav, because the conventional siege artillery was more than adequate for the job, and the gun's contribution was real but not decisive, impressive but not necessary, and certainly not worth the resources invested, when those same resources could have produced weapons that would have been useful on other fronts. The verdict on Gustav's combat debut was mixed. The gun had worked as designed. It had destroyed targets that would have been difficult or impossible for conventional weapons to reach, and the psychological impact of watching 7-ton shells arc through the sky was undeniable. But operational limitations were also clear. 5 weeks to position, 3 weeks to assemble, vulnerable during the entire preparation phase, immobile once emplaced, limited ammunition, and a worn-out barrel after just 48 shots. And the strategic reality was that Sevastopol would have fallen in July 1942, whether Gustav fired 48 rounds or 0 rounds, because the German artillery concentration was overwhelming, and the Luftwaffe controlled the skies, and the Soviet defenders were isolated and running out of supplies. Gustav was a spectacular sideshow in a battle won by conventional weapons and superior German firepower across the board. But the gun had finally been used in combat, and now the question was what to do with it next. Sevastopol's fall brought Gustav's disassembly and movement north to the outskirts of Leningrad, the city now known as St. Petersburg, where another siege was underway, and German planners thought the gun might prove useful in breaking Soviet resistance. Positioning the weapon 30 kilometers from the city near the Tatsi railway station, crews went through the entire assembly process again over several weeks, laying track, positioning bogies, hoisting the barrel into place, and preparing to fire. Late 1942 found Gustav fully assembled, operational, and ready to rain 7-ton shells down on Leningrad's defenses, and the crews waited for orders to commence firing, and they waited, and they kept waiting, because the orders never came. The planned German assault on Leningrad was canceled when Soviet defenses proved stronger than expected, and the German offensive stalled, which meant Gustav sat idle through the entire winter of 1942 into 1943 without firing a single shot. Think about that for a moment. 5 weeks to transport the gun, 3 weeks to assemble it, 1,500 men devoted to its operation, and the weapon never fired because the battle it was supposed to support never happened. All that effort, all those resources, all that time, and Gustav's contribution to the Leningrad siege was exactly 0 rounds expended, 0 targets destroyed, 0 strategic impact. Dora, the second gun, presents a murkier situation because historical accounts conflict about what actually happened with this weapon. Some sources claim Dora was deployed near Stalingrad in September 1942, positioned about 15 kilometers west of the city, and made ready to fire on September 13th. But the gun was quickly withdrawn when Soviet forces threatened to encircle the German position. And these sources say Dora either never fired or fired only a handful of rounds before being pulled back. Other sources claim Dora never existed as a separate gun at all, that it was just a nickname the artillerymen used for Gustav, and confusion arose from people hearing different names for the same weapon. Evidence suggests there were actually 2 guns built, because Allied forces found wreckage of 2 different gun carriages about 80 kilometers apart after the war, with Dora's remains discovered at Grafenwöhr and Gustav's remains found north of Auerbach. But exactly what Dora did or didn't do during the war remains disputed. claims exist that Gustav was used at Warsaw in 1944 during the Polish uprising, with some sources saying the gun fired about 30 shells into the city during the German suppression of the rebellion. But other sources dispute this entirely and point out that photographs of captured railway guns at Warsaw show weapons that were clearly smaller caliber than Gustav's 800 millimeters, probably K-12 guns or similar weapons. The Warsaw Uprising was crushed before super-heavy artillery would have been needed anyway, so it's entirely possible Gustav was never there. What we know is that a third gun was planned, called Langer Gustav, meaning Long Gustav, and this version was supposed to have a longer 52-centimeter caliber barrel capable of firing shells out to 190 kilometers, or about 118 miles, which would have given Germany an extremely long-range bombardment capability for terror bombing of distant cities. Langer Gustav was still under construction in 1944 when Allied bombing raids damaged the partially completed gun beyond repair. The project was abandoned and the unfinished weapon was scrapped. December 1942 brought Krupp proposing an even more insane project called the Landkreuzer P-1500 Monster, apparently not satisfied with building the largest gun in history. The concept was mounting Schwerer Gustav on a tracked chassis to create a self-propelled gun that wouldn't need railway tracks, and the specifications were characteristically absurd. The vehicle would weigh 1,500 tons, measure 35 meters long and 14 meters wide, and be powered by 4 Daimler-Benz diesel engines plus 4 Maybach gasoline engines to achieve a top speed of 15 to 20 kilometers per hour. Armament would include the 800mm gun as the main weapon, supplemented by 2 150mm howitzers and side sponsons, and numerous MG-151 machine guns for anti-aircraft defense, and the goal was giving Gustav cross-country mobility independent of railways, allowing it to support direct assaults instead of being limited to static siege positions. The P-1500 monster never progressed beyond paper proposals because even the Nazi leadership recognized it was completely impractical. Albert Speer, Germany's armaments minister, canceled the project and redirected the resources toward producing tanks, aircraft, and other weapons that might actually affect the war's outcome. And the P-1500 exists today only as technical drawings and a reminder that there was apparently no idea too ridiculous for serious consideration in Nazi Germany's weapons development programs. As 1943 turned into 1944 and then 1945, Germany's military situation deteriorated rapidly with Soviets advancing from the east, Western allies from the west, and Germany's industrial capacity being systematically destroyed by strategic bombing. Somewhere in this chaos, Schwerer Gustav and Dora were moved around trying to stay ahead of advancing Allied forces, but their fate was sealed because Germany could not allow such weapons to fall into enemy hands intact. Exact dates are uncertain, but sometime in early 1945, probably late March or early April, German engineers received orders to destroy both guns to prevent their capture. Gustav was blown up with explosives in a forest about 15 kilometers north of Auerbach and roughly 50 kilometers southwest of Chemnitz, and the ruins were discovered by Allied forces on April 22, 1945, just days before Germany's final surrender. Dora met a similar fate on April 19, 1945, when German engineers detonated explosives on the gun near Oberlichtenau, specifically to deny it to the approaching Soviet army. And American forces later found the blasted remains at Grafenwöhr, photographed the wreckage for intelligence purposes, and confirmed that the gun had been thoroughly destroyed. Both weapons were subsequently scrapped for their steel value, and today, no large pieces of either gun survive. A few inert shells and shell cases are preserved in various museums, including the Imperial War Museum in London, which displays an 800mm shell next to a Soviet T-34-85 tank to give visitors a sense of scale. But the guns themselves exist only in photographs, technical drawings, and historical accounts. Americans and Soviets both examined the wreckage and filed technical reports analyzing the weapon's design and capabilities, and their conclusion was unanimous. Schwerer Gustav was an engineering marvel and a tactical disaster, a weapon demonstrating impressive technical capabilities while accomplishing almost nothing of strategic value. Post-war analysis showed that Germany had invested 10 million Reichsmarks per gun, devoted thousands of men to operating weapons that fired fewer than 100 rounds combined in the entire war, and tied up manufacturing capacity that could have produced hundreds of tanks or aircraft. Resources spent on Gustav and Dora would have been far more effective if used for literally any other weapon system. And so, the largest guns ever built ended their existence as piles of twisted steel in German forests, destroyed by their own creators to prevent them from being studied by enemies who had already won the war. The monsters that were supposed to smash through the Maginot Line and bring cities to their knees had fired a few dozen shells, destroyed one ammunition dump, damaged some fortifications that conventional artillery could have handled, and then vanished into scrap metal and historical footnotes. Let's do the mathematics of failure. 10 million Reichsmarks per gun, 2,500 men required to operate a single weapon, 5 weeks minimum to position and prepare for firing, 3 weeks just for assembly, and approximately 48 rounds fired in combat by Gustav, with Dora's contribution either zero or minimal, depending on which historical account you believe. One ammunition dump spectacularly destroyed, several fortifications damaged that conventional artillery could have handled just as well, and 0 cities conquered thanks to Gustav, 0 battles won by its deployment, 0 strategic objectives achieved that justified the investment. What could Germany have bought with 10 million Reichsmarks instead of one giant gun? 97 Panzer, 4 medium tanks, the workhorses that actually won battles on the Eastern Front and in North Africa, or 200 Messerschmitt B, F-109, fighters that could have contested Allied air superiority, or 40 Junkers Ju, 88 bombers for tactical strikes, or fuel for thousands of vehicles for months of operations. Any of these alternatives would have had greater strategic impact than Schwerer Gustav, and all of them could have been deployed in days rather than weeks and moved to where they were actually needed. Tactical reality showed that Gustav was only effective in static siege warfare, and World War II was fundamentally a war of movement. Blitzkrieg doctrine that Germany pioneered emphasized speed, maneuver, combined arms coordination, and exploiting breakthroughs before the enemy could respond. And Gustav embodied the exact opposite of every one of these principles because by the time the gun was positioned, the battle was often already decided, and the weapon had no mobility, no flexibility, and no ability to respond to changing tactical situations. Logistics were a nightmare from start to finish. Extensive railway infrastructure, including 4 parallel tracks at the firing position, curved track sections for traverse, and the entire system, vulnerable to partisan sabotage of the railways that supplied it, defined the requirements, and ammunition was massive, expensive, and slow to produce with apparently only 48 rounds available for the Sevastopol deployment. Barrel life lasted about 300 rounds total before relining was required, and relining meant sending the barrel back to Krupp's factory in Essen for work that would take months, leaving the gun out of action for extended periods. Why did Gustav fail so completely to live up to its promise? First, it was designed for the wrong war, built to fight World War I-style static trench and fort warfare, when World War II demanded mobility and rapid response. And second, it was too slow, requiring weeks to position when battles lasted days, and maneuver warfare moved faster than the gun could be repositioned. Third, it was too specialized, only useful against the heaviest fortifications, when most targets could be destroyed with conventional weapons. Fourth, it was too expensive, consuming resources that would have been far more effective if spent on mobile weapons that could be deployed on multiple fronts. And fifth, it was too vulnerable, sitting exposed during weeks of assembly and positioning with no ability to defend itself beyond anti-aircraft guns. Sixth, it was too limited in range, with 48 kilometers being impressive, but not revolutionary when conventional heavy artillery could reach 20 to 30 kilometers for a fraction of the cost. And seventh, it contradicted German military doctrine, because the Wehrmacht's entire philosophy emphasized speed and maneuver and combined arms coordination, and Gustav represented the opposite of all these principles by being slow, immobile, and unable to coordinate with other forces effectively. Propaganda value was real but temporary. German newsreels showed Gustav at Sevastopol and portrayed it as an unstoppable wonder weapon, demonstrating German technological superiority. And for a brief period, it probably did boost morale to know that Germany possessed the largest gun in history. But propaganda can't substitute for tactical effectiveness, and reality never matched the newsreel footage. As an engineering achievement, Gustav remains impressive even today. Largest gun ever built and still holds that record. Largest caliber rifled weapon ever used in combat. Heaviest mobile artillery piece ever constructed by total weight, and it fired the heaviest shells of any artillery gun in history. Technical challenges Krupp overcame in machining, metallurgy, and mechanical engineering were genuinely remarkable, and the fact that the gun actually worked as designed and could fire 7-ton shells 29 miles with reasonable accuracy testified to German engineering capabilities. But technical achievement doesn't equal strategic value, and this is where Gustav's story becomes a cautionary tale, because bigger is not always better, especially in warfare where mobility, flexibility, and efficient use of resources often matter more than raw destructive power. Complexity is a liability in war because complex systems break down more often, require more specialized maintenance, and can't adapt to changing circumstances as easily as simpler systems. Mobility matters more than raw power, because a weapon that can be where it's needed quickly is more valuable than a more powerful weapon that takes weeks to position, and resources are finite even for major powers, and choosing to spend them on one weapon system means not spending them on alternatives that might be more effective. Solutions designed for yesterday's problems rarely work well for today's challenges, which was exactly Gustav's situation, since it was built to fight the last war rather than the current one. Irony runs thick throughout Gustav's history. Designed to destroy the Maginot Line, but the Maginot Line was bypassed without Gustav firing a shot. Deployed to Sevastopol, where the city would have fallen anyway, thanks to overwhelming conventional artillery and air superiority. Moved to Leningrad, where it never fired because the assault was cancelled, may or may not have been prepared for Warsaw, where the uprising was crushed before it could be used. Cost millions of Reichsmarks, but achieved nothing conventional artillery couldn't accomplish. Took years to build, but was used for only weeks. Survived all its testing, but was destroyed by its own creators before the war ended. From a modern perspective, Gustav represents the absolute peak of the big gun era, the moment when artillery reached its maximum size before evolving in a completely different direction, and modern artillery emphasizes mobility, accuracy, and range rather than sheer size, with self-propelled guns that can shoot and move quickly, guided munitions that hit targets precisely rather than relying on massive explosive power, and range achieved through better propellants and lighter shells rather than enormous barrels. Gustav's 48-kilometer range is now routine for modern artillery systems that weigh a fraction of what it weighed and can be positioned in hours rather than weeks. And precision matters more than shell size in contemporary warfare. And a guided munition can destroy a target with a 50-pound warhead that would have required a 7-ton unguided shell in 1942. Principles that made Gustav obsolete in World War II have only become more relevant in the decades since. Final word on Schwerer Gustav is that it was engineering excellence without strategic wisdom, raw power without tactical purpose, a monument to hubris and the danger of pursuing technical achievement for its own sake without considering whether the result would actually be useful. Largest gun mankind has ever built and one of the most useless, a weapon that fired fewer shells in combat than some individual field guns fired in single battles. And it stands as the ultimate example that bigger isn't better. 48 rounds fired, one spectacular hit, thousands of man-hours wasted, millions of Reichsmarks spent, and the result was a footnote in military history rather than the war-winning weapon Hitler and Krupp envisioned. Schwerer Gustav changed nothing, influenced no major battles, and contributed almost nothing to Germany's war effort beyond providing material for propaganda newsreels. Legacy exists as a cautionary tale about the danger of technological overreach, the importance of matching weapons to doctrine, and the reality that the most impressive engineering achievement isn't necessarily the most effective military weapon. Sometimes the solution to a problem isn't to build something bigger, but to build something smarter, and Schwerer Gustav represents the road not taken, the moment when artillery could have evolved toward precision and mobility, but instead went for one final exercise in maximum size before the entire concept became obsolete. The largest gun ever built sits in history as a monument to waste, a reminder that wars are won by effective use of resources rather than spectacular demonstrations of engineering capability, and a testament to the fact that sometimes the most impressive weapon is also the biggest failure.